It's a peak summer afternoon. You're sitting in a closed room where the air feels heavy and stagnant, trapping the heat until the entire space feels like an oven. You reach over and hit the power button on the air conditioning unit. Within seconds, a sharp, icy blast of relief hits the room and begins to circulate. Frost, it's easy to assume the AC unit acts as an ice factory, manufacturing coldness to pump into the space. But there is no ice inside the machine, and physics dictates that we can't actually create coldness out of nothing. To understand what's actually happening, we have to look at the machine from a different perspective. The secret is found by tracking the path of the hot air that was already in the room when you turned the unit on. Cooling a home is a relocation problem. You have to find the heat and move it somewhere else. If you look directly at the unit's intake vent, you can see where the process begins. Internal fans pull that warm room air into the front of the unit. Inside, the air meets the first major hurdle, a cold coil. This coil is filled with a specialized cooling liquid called refrigerant that cycles through the tubes. As the warm air moves over this cold coil, the two temperatures meet at the metallic surface. This is the moment of thermal exchange. The refrigerant actively absorbs the heat, stripping the energy right out of the passing air. This contact point is the engine of the entire system. The air loses its heat to the coil rather than being injected with cold. Once the air crosses that coil, the machine executes two different actions at the same time. First, the fans blow that newly chilled air forward, out of the front vent. This air returns to your living space, significantly lower in temperature. But we also have to account for the heat that the refrigerant just pulled out of that air. The machine pushes this absorbed heat toward the back of the unit, behind the window line. This heat is released out of the back of the unit and dumped directly into the air outside. Lowering the temperature indoors requires this constant cycle of extraction, ensuring the heat is expelled before it can settle back into the room. Now the room is chilled and comfortable. That drop in temperature happened because the machine is systematically removing energy from the room. The AC unit operates as a dedicated heat relocator. You can think of it as a mechanical conveyor belt, constantly grabbing heat from your room and throwing it out the window. The internal chemistry of the refrigerant and coils is complex, but the physical result is simple. Staying cool on a summer afternoon depends entirely on the machine's ability to act as a bridge, moving energy from where it's unwanted to the world outside.